volunteers with a lot more nonprofit and development experience than I have. Took it all from there, and the past year have been exploring our healthcare community here and the needs of women in Santa Barbara County. And through that work, they became connected with Dr. Emily Jacobs, a neuroscientist from UCSB, and our speaker tonight. So her work is absolutely fascinating. So before I introduce her formally, I just wanted to give a few thank yous to the event sponsors, which are the Ann S. Bowers Women's Brain Health Initiative, the Walter H. Capps Center, and the Health Humanities Initiative at UCSB, Babcock Winery. We have some really good, this is like a wine tasting event here, so Toma Restaurant, and the Direct Relief Team. We are extremely thankful for them opening this beautiful space, particularly thanks to Rose Levy and Martha Vasquez. And the next thing I'm going to do is introduce the people who made this event possible, because I was truly, when I say I wrote an op-ed and started this little coalition, but none of this work is mine. I think it's really important to recognize the women who have done all the work here. So this is Kristen Adams from the Women's Health Coalition, Carrie Robinson from the Women's Health Coalition, and Liz Hollihan from the UCSB affiliate. So I'm going to just give them a moment to introduce themselves and update you, and then I'll be back to give a formal introduction to Dr. Jacobs.
Thank you everyone so much for coming. I'm Liz Hollihan, Development Coordinator. I'm just going to do that. Development Coordinator at UC Santa Barbara. I'm honored to be here tonight to represent the UCSB affiliates, which is a program dedicated to building and celebrating connections between UC Santa Barbara and the greater Santa Barbara communities. We're passionate about creating innovative and community-centered programming. And just like tonight's event, we want to spark conversation and invite collaboration. So we're so excited for everyone to be here. Our volunteer board was inspired by Dr. Jacobs' research and her dedication to community-engaged scholarship. I want to give a shout out to Jane McTaggart and Connor Rehage who are in the room, part of the UCSB Affiliates Board. Thank you so much for all your support. And we're thrilled to partner with the coalition to share this important research. I want to give special recognition to Carrie Robinson, Associate Director for the Health Humanities Initiative and a member of the coalition, who has been just absolutely instrumental in making this event happen between all these groups. And so we're really looking forward to continuing this partnership with future community events. So now I'm going to turn it over to Kristen.
Hello everyone, I'm Kristen Adams. I'm here tonight on behalf of the Santa Barbara Women's Health Coalition. We are a new grassroots organization that's dedicated to advancing women's health care in Santa Barbara. We have 3 objectives that guide us. First, to build a welcoming and inclusive community around women's health. Second, to understand the challenges women face, or better understand the challenges women face throughout the life cycle. Over the past year, since we got our start, we led focus groups to specifically learn more about the needs of the adolescent population, as well as maternal and reproductive health and menopause and aging. We still have a lot of learning to do, and we want to invite this group and the community to do that with us. Our third and final objective, and what tonight's all about, is fostering new connections. We recognize that there's already work being done in the community by people to advance healthcare, specifically women's healthcare. And so we wanted to use tonight to promote learning and collaboration and foster new connections. As we delve into the discussion ahead, we invite you to learn with us, to go out and meet some new people after the fact, and then to just appreciate the efforts that are underway locally and beyond. All right.
So it is my honor to introduce Dr. Emily Jacobs. She is an associate professor of psychological and brain sciences at UCSB. And I have a feeling she's probably on the younger side for associate professor. Anyone in academia is probably aware of the challenges to moving up. So I'm sure it's secondary to all of her incredible research that she's doing in her impressive resume here. She leads the Jacobs Lab at UCSB using brain imaging, endocrine, and computational approaches to deepen our understanding of hormone action in the brain. Before joining UCSB, she was an instructor at Harvard Medical School. She is the recipient of numerous prestigious national awards, including being named one of the 10 scientists to watch by Science News in 2022, receiving the University of California Hellman Fellowship in 2009, bestowed to support research efforts of the most accomplished junior faculty members in the UC system. Being awarded the 2018 Brain and Behavior Young Investigator Award, being named a National Academy of Sciences Frontiers of Science Fellow for Distinguished Young Scientists under 45 in 2016, and she received a 2012 NIH Health Career Development Award. Most importantly, she currently serves as a principal investigator for the Women's Brain Health Initiative, a University of California-wide brain imaging consortium designed to accelerate the pace of discovery for women's health. Please join me in welcoming Dr. Jacobs.
Sound okay? Okay, good. It is an absolute honor to be here, and I will just give a little bit of backstory. First, huge thanks to the leadership of the coalition, as I like to call it, the Santa Barbara. Can you hear? Oh no, okay. Oh, we should use this one. Is that better? How about that? Can you hear me now? That's good? No? Okay, we're gonna get it. How about this? Okay, good. Okay, I may walk around. So huge thank you to the coalition, Santa Barbara Women's Health Coalition, for a true grassroots campaign to build what we are about to build, what they have started and what tonight is all about. I will say that I first came across the coalition, I think it was in the middle of the pandemic, and I was reading an article in the Montecito Journal about this new spark that had been lit from Dr. Mitchell, and I think I emailed them right away and just said, how can I be a little barnacle on the great work that you're doing? How can we align our interests and help? And that led to a series of conversations, weekend conversations and meetings, and truly we are just getting started. So these are the women that you have to thank for whatever is about to come, and I'm excited to see what that is. So this is going to be a little bit of a different talk. As you may have gathered, I'm a neuroscientist by training, but in addition to sort of the basic lab work, over the last few years, I've realized that there's sort of an important consideration to think about, which is the intersection between gender equity in the sciences and the status of women's health, not as concurrent phenomenon, but as deeply connected ones. So I want to take you on a journey of what I mean and why it matters for understanding why women's health may be 20 years or more behind where it should be, where it could be. And I'm going to use the lens of neuroscience just because that's my background. So at first glance, the human brain looks pretty unremarkable, like a big 3-pound squishy walnut. But if you zoom in at the microscopic level, it contains multitudes, over 85 billion neurons that are wired together into precise circuits. And these neural circuits are responsible for an incredible repertoire of complex human behaviors. Think about it. That is capable of writing an opera. It can invent the tools that allow us to see into the deepest corners of space. Perhaps even more profoundly, the human brain can invent tools to see and study itself. When President Obama launched the Human Brain Initiative in 2013, 10 years ago, He said that understanding how the brain works is one of the greatest scientific challenges of our time. It's the moonshot of our generation. Right now, around the world, neuroscientists are trying to crack the neural code to understand how the brain gives rise to the mind and to identify therapeutic solutions to devastating disorders like Alzheimer's and Parkinson's and depression. If we have any hope of meeting this challenge, we need the best minds at the table and in the lab, inventing radically new ways of seeing, probing, and understanding the brain. We have some work to do. By the way, of the remainder, only 5% of tenured positions are held by women of color. And what happens if a woman lands a coveted faculty position? She's paid less, she's given a smaller startup budget, and she's equipped with less lab space than male colleagues with similar academic achievements. I'm not going to go into the long history of sort of explicit biases that have kept women out of higher education. There's other writers and scholars who have chronicled those parts of our past. I just want to drive right to the crux of the problem. Advocating for diversity in science or advocating for the equitable distribution of resources in science isn't just a matter of social justice. It's not just the right thing to do. Diversity in science makes science better. It drives innovation, it challenges the status quo, and it changes the very nature of the questions we think to ask. As Siddip Parikh writes, the reason for diversity transcends the moral imperative. It's about inventing technologies that will grow the economy and bring medicines to fruition faster. In other words, the absence of women from science isn't just about the cost to women, it's about the cost to the world. Here's one example. Biomedical research relies on animal models to understand diseases, to test therapeutic treatments, and to advance knowledge of basic biology. And to this day, most biomedical research is conducted in males. That discovery was made in part by a woman, Annalise Beery, back in 2011, while she was a postdoctoral fellow at UC Berkeley. She put real numbers to a quiet convention now known as the sex bias in basic science. So there's this over-reliance on male animals in preclinical research, and it's evident throughout the biomedical sciences. Neuroscience happens to be the biggest offender. Here's the craziest part. This is even true for animal models of human disorders that are more prevalent in women, like Alzheimer's, depression, and anxiety. Take, for instance, depression. Here's a clinical disorder that's twice as common in women than men, and yet the vast majority of animal studies of depression are conducted in males. This bias is compromising the health and safety of women in ways we are just beginning to understand. According to a report issued by the US Government Accountability Office, about 75 to 80% of drugs that are pulled from the market every year by the FDA are done so because they have adverse effects in women. Effects that might have been caught earlier on had that preclinical testing included both sexes. So in short, the scientific body of knowledge is not serving the sexes equally. Most of what we know about health and disease is centered on the male body. As the philosopher Kathleen Krulik once wrote, the treatment of menstruation, pregnancy, and childbirth as diseases or medical emergencies may be traced to the fact that these are not things that happen to the ideal healthy human being, who is, of course, male. The ideal healthy lab rat is also male. His body, his hormones, and his behaviors define the norm, so he is used in experiments. She goes on to say that the dangerous effects of such research procedures, especially in the biomedical sciences, are just now being documented. For far too long, the assumption underlying these experimental designs that males are the norm just went unchallenged. Women are the majority of the population, but we are not yet seen as the norm. We have got to correct course for biomedical research to advance and for quality of clinical care to improve. And look, these are not new problems. Medicine has been afraid of women's bodies throughout history, dating back to the time of antiquity when Hippocrates proposed that a woman's womb could wander throughout her body, wreaking havoc. This is a luminous book written by Eleanor Cleghorn, in which she chronicles the history of how medicine has failed women by treating our bodies as unknowable. She writes that medicine has insisted on pathologizing femaleness, and by extension, womanhood. Our diseases are not elusive to us, but something about our diseases seems to thwart and frustrate medicine at every turn. Dating back to the late 1800s, the time of Charcot de Salpêtrière, hysteria was handed out as a diagnosis for any female pathology that physicians just failed to understand. And our lives depend on medicine learning to listen. So how come in the year 2023, women don't have answers to fundamental questions about their body? It starts with education. 80% of medical schools fail to include menopause in the curriculum. And for those that do, the courses are mostly an elective. So if you need the bumper sticker, here it is. Women's bodies are not an elective. It's not just menopause. A recent survey of pediatricians found that 1/3 didn't know the median age when menstruation begins, 12 to 13 years. And 20% didn't know whether there was a minimum age at which it was safe to start using a tampon. There isn't. Women's health is not a luxury. We can do better. I'd love for you all to read this op-ed penned by El Morada, who's here in the audience today, if you want to wave. Elle's a PhD student in the lab, and in this piece, she does a beautiful job chronicling her own experience of confronting a healthcare system here in Santa Barbara that was unprepared to answer basic questions about her health. She was eventually diagnosed with polycystic ovarian syndrome, or PCOS. PCOS and endometriosis, these are disorders that affect 1 in 10 women. And yet the average diagnostic period, so from the time between when symptoms emerge to when you get an accurate diagnosis, that's about 5 to 10 years for these disorders. That's too long to live with the unrelenting pain of these disorders. Why is our medical system so unprepared to answer questions about women's health, as Elle states in her article? Okay, so here's another example. This one hits a little closer to home because it comes from my own field of neuroscience. So a little history of our field. So the use of brain imaging technology like MRI has really given us unprecedented insight into the human brain. Now, this technology entered the fray in the mid-90s, so we have about 30 years of research using this technology. And since then, since the mid-90s, there's been this just stunning growth in the number of brain imaging publications that have come out, captured here by, let's call it this blue wave. In yellow, as a reference point, you can see the number of brain imaging publications on depression. And then if you squint really hard, you can see the thin black line at the bottom. That's the totality of articles covering menopause, pregnancy, hormonal birth control, the menstrual cycle, and much, much more. So altogether, studies of these women's health factors constitute less than half of 1% of the brain imaging literature. By ignoring these factors, we risk making at least 2 major mistakes. First of all, the brain is an endocrine organ, and yet research scientists and clinicians have almost no insight into how dynamic changes in sex hormones shape the human brain. And second, we're missing critical clues about why endocrine transition states may be a period of both resilience and vulnerability. For 30 years, the neuroscience community has underserved women. Or to put it in a more positive light, progress in healthcare will flourish if and when the health of men and women are valued equally. As we said in an article a few years ago, neuroscience has overlooked aspects of the human condition that are relevant to half of the world's population and half of the tax base, and we've got to correct course for the field to advance. To understand why this matters, let's talk about 2 leading causes of disability worldwide: depression and dementia. Here are 2 disorders in which women outnumber men 2 to 1. Of the 6.7 million Americans living with dementia today, 2/3 of them are women. We see a similar pattern with depression, where women are at twice the lifetime risk relative to men. what happens if we take a step back and we start to think about these disorders through the lens of women's health? You start to see an interesting pattern emerge. For example, over the life course, the incidence of depression co-occurs with endocrine transition states: puberty, hormonal contraceptive use, the postpartum period, perimenopause. We know that early menopause is a risk factor for dementia, and early surgical menopause has been associated with greater burden of neuritic plaques at autopsy. Gaining traction on these disorders depends on our willingness to invest in women's health from bench to bedside. And there is a lot of work to do. Women's health is underfunded, it's understudied. So when we talk about the scientific body of knowledge, we've got to ask, whose body does it serve? So here's the ultimate case for diversity. Scientists cannot answer questions they don't see. So a field like neuroscience that has traditionally been led by men, it's likely that the menstrual cycle or pregnancy or menopause were never visible. Just like studying male animals in the lab didn't seem strange until somebody comes along and challenges all those ingrained assumptions. So what are all the other questions we can't see because we lack the experience to even imagine them? We need scientists, clinicians, and leaders in our healthcare community whose vision isn't blurred by the lack of experience. It's become clear to many of us in this space that positioning women's health as equal to men's health is going to require a global shift in science culture. That shift starts now. It starts right here. All of us can use the tools, the talent, and the time that we have to push for change in whatever space you're in. So for me in my lab, the tools that we have are in the lab. So I'm just going to share just a little bit. Is going to sort of moonlight as a neuroscience talk too. So I just want to share a little bit of what my lab is doing over at UCSB to shine a floodlight on women's brain health. So we are interested in how the brain changes across neuroendocrine transitions like the menstrual cycle, pregnancy, menopause, or in response to hormone-based medications. Now, often the brain is sort of thought about like this, right? Like in isolation from the rest of the body. In fact, it is deeply connected with everything down south of the neck. We know that sex hormones produced by the gonads, ovaries, and testes are powerful neuromodulators in the brain. So in fact, about 50% of the brain cells, the neurons in your frontal lobe, contain the receptors for these hormones. So these are circuits that are just primed and ready to be responsive to these hormonal signals. And yet the bulk of our knowledge of neuroendocrinology really comes from animal models. And how hormones influence the structural and functional architecture of the human brain is still a big mystery. So in just a few slides, I want to convince you that by ignoring sex hormones, we're almost certainly missing a major driver of the dynamic changes in the human brain over the life course. Here's just one example. So this is a project led by a graduate student, Laura Pritchett. She scanned a woman's brain, in fact, herself, and drew blood every 24 hours for 30 days across a complete menstrual cycle. So this is capturing the rhythmic changes in hormones that happen across a canonical cycle, which you can see in this image here. So there's this ebb and flow of hormones. You can see this surge in estrogen in teal, this rise in progesterone in what's called the luteal phase of the cycle in blue. This is a new area of neuroscience. It's come up sort of gained in popularity over the last 5 years or so. It's called precision imaging. The idea is that we can follow really small groups of individuals with super high temporal resolution and over long periods of time to understand the dynamics of the brain. So instead of just getting a snapshot of the brain, we can actually see how it's changing over time. I always like to put this quote up because it makes me laugh. One editor later said, they were like old school NASA test pilots. They put themselves in an MRI scanner and drew their own blood every day for 2 months. Rest assured, if there's anybody on the IRB board, we had a certified phlebotomist. We did not draw our own blood. So one thing to keep to sort of note here is that a central feature of the mammalian endocrine system is that hormones ebb and flow over time. So you see this waves of secretion. And for some women, this ebb and flow is as steady as the tides. This pulse is almost like a vital sign because these rhythmic changes drive physiological changes throughout the body. But nobody really knew how they shaped the brain until now. So Laura discovered that these transient increases in estrogen across the menstrual cycle can drive increases in connectivity across the brain. Now, at the microscopic level, we know that estrogen is like Miracle-Gro for neurons in the hippocampus, leading to increases in synaptic plasticity. There are also dynamic changes in brain volume across the cycle. So this is work done by Caitlin Taylor, who's also here today. Caitlin used really high resolution brain scans to map a region of the brain called the hippocampus, and she did so across the menstrual cycle. So on the left, so seeing how the volume of this tissue might change over the natural cycle. And then she did it all again in a second experiment. This time, the participant was on a drug that squashed progesterone levels by about 97%. So notice that blue wave in the first graph is absent in the second. And here's what she found. When progesterone levels are naturally elevated in the second half of the menstrual cycle, this is called the luteal phase, we see this expansion of gray matter volume. But if you pharmacologically suppress progesterone, you can abolish this effect, shown here. And by the way, the drug used in this experiment is the most common form of hormonal contraception, the pill on the market today. What about other endocrine transition states? We know that the endocrine changes observed across the menstrual cycle are dwarfed by those that are observed across pregnancy. So we have a new precision imaging study where we're tracking women across pregnancy with MRI and blood draws beginning preconception and continuing every 2 weeks or so across the complete gestational window through 2 years postpartum. So you can see sex hormones in this lower left graph. There's this incredible rise, right? So you see these increase in sex hormone concentrations across gestation, and then they drop precipitously at birth. And across pregnancy, we can see these sweeping changes in gray matter volume in the middle panel and white matter microstructure. So in this case, gray matter volume has this sort of stair-step decline from preconception to the postpartum period. We can, in the Q&A, we can get into what this means. Decline is not a bad thing. So the analogy I like to give is to think about Michelangelo's David. He starts off with a big hunk of marble and he chips away to reveal the underlying beauty. We're seeing evidence of the same thing happening here, where this new sort of period, matrescence, is likely this period of extended neuroplasticity. We can also see an increase in white matter microstructure over the same period of time. This is the first atlas of the human brain across pregnancy. It's the first time scientists have charted how the brain changes week upon week during this period of time. It's 2023. So it turns out that the maternal brain may hold some of the greatest mysteries of the brain, like its ability to undergo directed plasticity in adulthood. People thought that this level of remodeling was more or less over at puberty. No. The brain holds superpowers if we just know where and how to look. And estrogen and progesterone seem to be guiding these processes. Another reason why sex hormones aren't nuisance variables that muck up the data, they are the data. So I hope you're beginning to get a sense of how responsive the human brain is to these major endocrine transitions like the menstrual cycle and pregnancy. And we can also think about at midlife with menopause. And by now, I think I'm beginning to sound like a broken record, but once again, here's a major opportunity for us to advance our understanding of the aging brain. From an endocrine perspective, menopause is a really interesting period. We can see that the production of sex hormones, so estrogen and progesterone, show this decline from premenopause to postmenopause. We also know that another hormone that spits out by a region of your brain called the pituitary increases. This is called follicle stimulating hormone, or FSH. It's actually used as one of the primary endocrine indicators of where you're at in the menopausal transition. During the menopausal transition, about 70% of women will report neurological symptoms. This may be brain fog, menopause fog, or mood disturbances. And yet the vast majority of studies of the quote unquote aging brain have completely ignored menopause. So indicated by this here. So again, you can see this blue wave of the number of studies on the aging brain, and then at the bottom in orange are the number of studies that consider endocrine aging or menopause. So my team has an ongoing study to understand how the brain changes and adapts across menopause. If any of you are interested, please reach out. We're constantly enrolling people, and we'd love to have your help. Understanding these neuroendocrine pathways could have important clinical implications for diseases like Alzheimer's. There's new evidence in mice that suggests that that hormone that I mentioned, FSH or follicle stimulating hormone, may act directly on neurons in the hippocampus to accelerate amyloid beta and tau deposition and impair cognition, and blocking FSH can stall these effects. So now is the time to take women's health prime time, and we can do that through deeply collaborative science. We're doing that through something called the Women's Brain Health Initiative, the Ann S. Bowers Women's Brain Health Initiative. For scientists, data is our currency, right? It's the thing that does the heavy lifting and solves the problems and changes lives if we gather it correctly. We need better data. And that recognition led to the formation of this new initiative, which publicly launches in November. We have neuroscientists at 6 institutions that have joined forces to build the world's most comprehensive brain imaging database designed to advance women's health research. And this initiative strikes at 3 levels. We use big data, deep phenotyping, and precision imaging to collect the data that has been absent for 30 years in the brain imaging community. You can go on our website and learn more about the details. Again, this is a deeply collaborative effort. It spans multiple institutions and disciplines with leaders in brain imaging, data science, AI, and women's health. So when we think about the status of women in science and the status of women's health research, it's easy to get angry. But there's actually a lot to be hopeful about. The NIH announced a few years ago that women's health would be recognized as one of 5 themes in the new strategic plan, which shapes the scientific agenda of 27 institutes and centers. We have allies in Congress, folks like Abby Finkenauer, who has chronic endometriosis, and when she was in office was trying to push to double federal research funding for a disorder that I mentioned afflicts 1 in 10 women. We have folks like Tammy Duckworth and Jan Schakowsky, who introduced a bill calling for the doubling of investment in women's health research. Look what happens when women step into positions of power. There's nonprofit organizations that are pushing hard for change too. There's folks like Rita Colwell at the NIS, Shirley Malcolm at the AAAS, who are calling for a concerted effort to name and dismantle biases that can lead to the underrepresentation of women and minorities in science. And there's an opportunity for the public. We are 51% of the population, we control 60% of the personal wealth, and we make 80% of healthcare decisions. Okay, I'm gonna end with a quote from Toni Morrison, the late, great Toni Morrison. She was once asked by a white interviewer whether her books would ever feature white characters in a significant way. And in her response, she says, "You can't possibly imagine how racist that question is. You're used to being in the center, and it's inconceivable to you that I could be mainstream." When the interviewer inquires about Morrison's success as a Black writer, she says, "I stood at the border, I stood at the edge, and claimed it as central. I let the rest of the world move over to where I was. Now is the time for women to claim themselves as central. We have got to claim the study of our bodies on our terms. And to do that, we need scientists and healthcare professionals whose vision isn't blurred by the lack of experience. I have spent a decade or more advocating for women's health to be taken as seriously as men's health in the biomedical sciences, and there are other incredible folks working on this front, but we can't do it alone. We need more women in positions of power. So how do we, as a society, how do we, as a community, hasten that along? please say hi if you are in the neighborhood. The lab is just down the street. We are always enrolling subjects for a number of the studies that I mentioned here, and I'd just like to end with a number of ways that all of you might get connected with the Women's Health Coalition. You can learn more about how to participate in studies, complete the event survey, so if there's other topics that you want to hear discussed, I promise it's not just a neuroscience organization, we're far more than that. Please contact the coalition on ways that you can get involved in this and come to some of our next events and join the mailing list. Thank you.
This is not necessarily a question, it is a remark. In the late 1980s and 1990s, I served on a lot of NIH review committees. These are the committees that review the proposals that come in for the research, and we decide who gets the money. And what was surprising at that time is they were saying, please review the proposals that have to do with women and minorities. And look at them more carefully because we need more of those. That was 30 years ago. And nothing much has happened since then. I will say it's important for women to propose more research.
Yeah, and I'll just add to that, a lot of this, so this notion of sex as a biological variable, that was identified by a woman who noticed, sort of peering down the hallway of labs at Berkeley, that most people were using males, so she decided to put numbers to that phenomenon. And once that hit mainstream, once that research got published and there was editorials in Nature and Science, New York Times, it hit the airwaves, and it caught the attention of Frances Collins, the head of the NIH, and Janine Clayton, who was the director of the Office of Research on Women's Health. And it was Janine who recognized what an impact, a potentially catastrophic impact that research practice was having on women. And she is the one who pushed for change. And it's not lost on me that it was a woman in a powerful position who wouldn't take no for an answer, and who I think is going to have an indelible mark on the history of science because of that, instituting new policy. So when scientists apply for research grants, right, we have to have money to run our labs, and we often do that through federal funding that the NIH, as you know, supports. Now, when you apply for a grant, there's a section on inclusion. So if you are proposing to only study male animals, you have to justify that. And unless you're studying testicular cancer, you sure as heck better include both sexes. But that only started in 2016. Yeah, it's wild. Any other questions?
I'm curious to know if there's a lot of neuroscience studies focusing on women who have been on hormonal birth control for many, many years. Because I know that that's quite common, and I think doctors are just kind of like, well, I don't know if it's good or bad, just like figure it out.
Yes. This is a huge topic of interest in my lab. I would say Dr. Taylor, who's sitting here in the second row, is the woman, if you want to raise your hand, that you should talk to, because she's leading this whole domain in our lab to understand broad forms of hormonal suppression, but also the pill and patch and IUD. And our attention in this space was really initiated when there was a study that came out now 5 or 6 years ago. This is a study that tracked the entire female population of Denmark. You can do this when you have integrated health records. And what they observed, they used a time-lagged analysis, and they observed that from initiation of the birth control pill or patch or IUD, any form of hormonal contraception, was lagged by about a 3 to 6 month at 3 to 6 months afterwards was followed by an increased risk for major depression. And this was true independent of the age at which you start OC, but they noticed that for adolescent users, the risk was the highest. This is something that is not at least in my experience, not talked about. So we need to educate our providers to say, look, and I will just sort of, in full disclosure, I think these medications are essential forms of healthcare. We need to protect and defend our right to have access to them. We also need to push the science forward. So we have an editorial in Nature Neuroscience that came out a couple of months ago that sort of pitches the idea of how neuroscience as a discipline can bring our weight to the table to really answer this fundamental question. What does the pill do to the brain? I will say there's 33 studies that have ever been published. That's not a lot. And they're all grossly underpowered. We're talking 20 people here, 30 people here. We need big data and AI to really understand. And I don't think it's going to be, is birth control good or bad for the brain? It's never that simplistic, but it might be, look, there's 10% of women for whom this does carry a significant increase in risk, and can we use precision medicine to identify them, to give them other forms of option? And maybe for 90% of women, we can say, you're good, go to town, it's all good. And we know that girls use birth control, hormone-based medications for all sorts of women, and they are often started young, by the age of 13, 14, 15, for acne, to control painful periods of undiagnosed PCOS or endometriosis, for a lot of reasons. And we do not have the neuroscience answers to understand the effects on the central nervous system. It literally doesn't exist. And that was actually, it's that question that sparked the development of the Women's Brain Health Initiative, which is now answering lots of questions, but that was really the main driver, this realization that, again, 30 years of brain imaging research and less than half of 1% of articles cover that, plus everything else. Yeah, Heather. Mm-hmm.
I'm curious to know if any of your research is overlapping with any kind of like environmental factors around hormones, and thinking of like young girls who are exposed to different kinds of foods, stress, and things that also affect their hormone changes. And is there a collaborative effort involved in that area?
That is such a good question, and I think we have exhausted the ability of the lab to take on any new approaches at the moment, but that is one that constantly comes up, which is essentially environmental exposures to endocrine disrupting chemicals. I think that would be, there's such a pressing need to understand that. There's great work in ecology, so looking at, let's say, waterways that flow into sort of freshwater ponds, and you can take samples from it and look at the concentrations of endocrine disrupting chemicals, and we know that it has striking effects on the reproductive development of reptiles. There's work in amphibians, there's work in frogs, looking at those that were sort of downstream of wastewater treatment plants, and they were exposed actually to massive amounts of hormonal contraceptives, because women will pass it through their urine and it gets pushed out into the waterways. And you can see wild things like the development of ovotestes, where basically they're not ovaries, they're not testes, it's like some aggregation of the two. So we know that environmental exposures can affect the reproductive tract. How it affects humans is begging to be done.
I'm curious if you could talk about all the ED recommendations for women in menopause for protecting their brains.
Yes. I would say so North American Menopause Society, NAMS, is a fabulous organization. This is the group that sort of comes together and has a consensus statement about things that you can be conscious of. It's all the things your mama told you, eat well, exercise well, sleep is very important. I would also put on the table that hormone replacement therapy is a really good option for some women. And there's a nebulous past in, when we talk about HRT, a lot of people remember the Women's Health Initiative study that sort of put the kibosh on studying or thinking about HRT for a long time. And maybe over wine we can get into it more, but that Women's Health Initiative study, I think, was designed to answer a different question than a lot of the public realized, because the average age of the women enrolled in that. So this is, I should back up. Bernadine Healy was the first female president at NIH, And she used her mantle to design this women's health initiative study. So this idea that half the women were going to be enrolled on hormone therapy and half would be enrolled on placebo. And they were looking at outcomes across the entire body. In fact, the sort of component that used brain imaging was very small. They were looking at cardiovascular disease, osteoporosis, etc. To give you a sense of the politics at the time, the Institute of Medicine came up with a position statement saying, it's unethical to run this study because the benefits of estrogen are so obvious that why would you enroll half of your women on a placebo and denying them the benefits of HRT? Fast forward 7 or 8 years after the clinical trial hadn't even finished yet, and they stopped it early because they found adverse risk effects of the women on HRT. So everybody thought, oh my God, HRT is this toxic, right? You can trace the number of women who were on, Prempro was the most common version at the time, the number of women who were on it, and then within 3 months after that hit the airwaves, uptake of the use of the medication dropped by 70%. But once you start looking into the design of that study, you realize it was actually asking a different question, because the average age of women enrolled in WHI were about 72. Women go through menopause at 51.8, 52. So that means that women who had gone through menopause 20 years later are now given this medication to see how it affects their body. Certainly for the brain adapts to that endocrine change. So now the consensus from the North American Menopause Society is that HRT can be incredibly useful medication if it's begun in that transition of perimenopause. So you don't let hormone levels flatline, you just supplement them, you soften the decline. But again, that's using the knowledge that we have. And I mentioned less than half the 1% of brain imaging studies have asked these sorts of questions. So we need more data to understand for whom HRT might be good or bad. But I think also, if you want recommendations, I think prioritizing sleep is probably a really good one. That's very easy to say when you wake up and you have hot flashes and it's hard to sleep. But then there again, I think that could be a mechanism through which hormone replacement therapy could derive its clinical benefit. There's lots of things that happen during sleep that we don't realize, like lymphatic clearance. So basically this like housekeeping system that like goes through your cerebral spinal fluid and clears out all of the sort of toxins that accumulate through the day. So, but if you have uninterrupted sleep, you don't get the benefits of that.
Along those lines with the hormone replacement therapy, is it just kicking the can down the road a little bit though? I mean, you take it for 3-5 years and then you're told to get off of it, and then you're kind of right back where you were 5 years ago? Or? It's
a great question. I know women who are 80 years old and they say, you won't pry this bottle from my cool hands. So maybe you have the can forever. Again, I mean, this is why we need healthcare professionals trained in menopause to ask these questions. Like, what is it about my unique health history that might preclude me from taking these things? Does having a history of hormone-responsive breast cancer change that calculus? There's some people, including the author of Estrogen Matters, who would argue that the increased risk is less than what flight attendants accumulate over a year by just experiencing elevated radiation. So we just need better data. These are all the kinds of questions that we need to be asking, and we do not have the data. So this is why it's got to be a conversation between pushing the science forward and having clinicians reading the science as it comes out, so that there can be direct translation of what we're doing in the lab and others working on other bodily systems, and how that can translate into improved care. Brigham and Women's Hospital has an entire group dedicated to hormone replacement therapy and thinking about whether it makes sense for you and how to manage what are the pharmacological and non-pharmacological tools that we have. We don't have that in Santa Barbara at all. There's no healthcare provider that specializes in a life transition that 50% of us will go through. This is why the needs assessment that the Santa Barbara Women's Health Coalition is putting out is so critical. What are the providers that are missing from our community that we need to bring in so that we're no longer in the dark?
My question is very well, it's probably more of a comment and not very well formulated, but I think that's just it. I think the best kind of what Santa Barbara or any place is someone who knows a lot about hormone replacement. And I think I'm
I hear you correctly when you said that 2/3 of the cases of Alzheimer's are women?
Yes.
Okay. That was surprising to me. And I'm just curious, do we know, does the science tell us yet to what extent the fact that women live longer than men, how much that plays a part?
Yeah, that's a great point. And for a long time, that's been the assumption that, women live longer, so we're going to get more of everything. And the science suggests that it's not that straightforward. That, for example, if you match people on clinical symptoms, here's a story of resilience. So if you match people as they transition from MCI to Alzheimer's disease, so mild cognitive impairment to Alzheimer's disease, you match men and women on the degree of their cognitive impairment. Women, and then you put them in a PET scanner and you look at the amount of amyloid in their brain. Women will harbor 20% more. But then when they start to decline, the decline is rapid. So it's like there's something that women are able to sort of go longer into the disease before it manifests. But then when it manifests, boy, it's a rapid decline. We're starting to think about menopause as this neurological transition state. All women go through it. Obviously, not all women go through menopause, but it may reveal
An underlying risk in some women. And this is where
it's probably a confluence of polygenetic risks, immune changes, but the sort of protective effects of estrogen on neurons goes away, and that might, again, for some women in a perfect storm, reveal the risk. So our dream is to, does anybody know the Framingham Heart Study? This is a nationwide study trying to understand cardiovascular disease, and it probably did more for understanding this disease and how to treat it than anything else. I want to see a national study of menopause where we can do, launching across 5 centers across the United States, geographically diverse women. We know that the experience of menopause is different for women of color than it is for white women, which is rarely talked about. But we need to be able to track women as they go through this transition and to do deep phenotyping, to look at, we know that there's really good blood-based markers these days. You don't have to put somebody in a PET scan to look at amyloid and tau. You can get pretty decent markers in the blood. So what are the earliest whispers of the disease that using big data and tools like AI, where you can do data agnostic quantification to see what are the earliest changes that might then lead to Alzheimer's down the road. The only way we're going to answer that is to do long-term prospective studies. Right now it's all retrospective from existing clinical trials. The other thing to think about is sex differences in treatment responses. So lecanemab, the anti-amyloid drug that got all of the press recently, buried in like Appendix 57 is this fact that lecanemab, to the extent that has a clinical benefit, and many neurologists would argue against that, to the extent that has a clinical benefit, it's only in men. There's no clinical benefit in women. That's never talked about. And the people running the clinical trials won't release their raw data, so we can't even do the sort of analysis that would help us understand why. Like maybe there's a gene hormone interaction. Maybe it's like ApoE4 carrier, so that the strongest genetic risk for Alzheimer's disease, sometimes there's an interaction between that and use of hormone, HRT, for example. They won't release the data. So that's another way we're pushing for change, is to be able to improve the reporting standards that are required by the NIH for these clinical trials, so that we can go back and do a sex and gender analysis to understand who are these treatments serving.
Thank you.
What is it like to participate in this study?
Yes.
I participated. I'm anxious to just say on behalf of everyone here, we all think it's brilliant.
Yeah, it's very easy. You just go and meet them all at the lab. And my study, I was there for a couple hours, and they gave me some lunch, and I was in the machine for a couple hours and got to do a lot of interesting memory games. And I encourage you all to participate and be part of the research. I promise that wasn't planned.
We have fun. It is a brilliant team. The people who are actually doing the work, many of them are actually in the audience here today. It's to to me, the biggest joy of what I get to do is seeing the next generation who are all going to start their own labs. And, as Georgetta always writes in her book, Middlemarch, you see the circles of life expanding. And I am ever an optimist, it's a Midwesterner in me, but I think it's a really exciting time to be in this space. It's a really exciting time for our Santa Barbara community because we all bring different tools to the table. So, this is just what we're doing in the lab from a neuroscience perspective, but think about all of the ways that we can push for change here in our backyard. Yes.
You talked about AI a couple times, and I was wondering if you can tell us about, it seems like that could be really helpful. Can you tell us about what's being done from that front?
Yeah, so the Women's Brain Health Initiative is, I mentioned, sort of involves lots of folks, and my partner in crime in this is this brilliant woman, Yumi Alon, who's in computer engineering. She's an AI ML whiz kid. The idea is that we can use, once we have accumulated a lot of data, we don't have to be limited by what our hypothesis is, right? I might think that, I might want to test some specific pathway, but sometimes you have to be agnostic with the data. And so what Nina specializes in is basically, how do you take a whole bunch of different types of data? It could be brain scans, it could be all of the things that we can get, all the fluid biomarkers that we can get from hormone levels, neuroimmune pathways, things like phosphorylated tau protein, all of the things floating in your blood. How do you get measures of lifestyle or health? All of that different structured data, you can put it into one data set and look for links that, again, might not be hypothesis testing, but are using computation techniques to show you who might be at risk of certain disorders and who might be resilient against them. So it's just a different analytical approach than a lot of kind of hypothesis-driven science.
Is it like a national data bank? Or?
Well, so what we want to develop, and I can just go back here, and you're getting a preview of this, but really, and you can go to the website to learn more, but that's the idea behind this Anna Bauer's Women's Brain Health Initiative, is to create the data that has been missing for 30 years. So this includes what we call big data, so we are uniting the University of California. So we're UCSB, right? But UCSB is just one tentacle of the mothership of the University of California. We've got 10 campuses, and right now we're partnering with 5 of them because most of these campuses have research-dedicated brain imaging centers. And all of that data, after it's sort of collected, sort of goes to waste. The idea here is that we're pooling all of that data. We're adding survey data so we can think about women's reproductive health history, and we're putting that into a central database that's managed by Stanford. As a guy named Russ Poljack, who is the world leader in open science. And once we collect that data, and we're aiming for thousands and thousands of subjects to participate, then we give it away. We give it away so that the global imaging community can do whatever they want with it. Remember the thin black line at the bottom? My goal is to see that visible on the screen. So if I give this talk in 10 minutes, that's my goal. I think we're out of time, but let's continue the conversation over wine.